All right. So last time we were looking at this, we looked at this what we called not what Alex calls non-group data, and basically what that is the the um, the data itself will naturally fall into specific categories. Like for example, the only outcomes are A, B, C, D, and E. All right. So the data is going to fall in one of those five naturally. But for what we call group data, then you really have to create classes on your own. All right. And so, because usually what that amounts to is the data is not going to fall into neat little cubby holes. You have to create the cubby holes. And these are the kind of the rules that we look at when we create these little data classes, they're called. Classes should all be the same width. The classes cannot overlap, because if they overlap, then you don't have a piece of data going into just um, one class. You got it going into two. Each piece of data should only belong to one class, and then no gaps. Because if there are gaps, then pieces of data are not going to go in. All right, so here's some classes that they've picked for us. 66 to 71, 72 to 77, 78 to 83, 84 to 89. And those all have a class width of 6. Now, it's a little bit hard to see that sometimes, but if you, let me put my camera, I don't have my camera there because I was going to do some counting on my fingers for you. All right. So if you've got 66, 67, 67, 68, 66, 67, 68, 69, 70, and then 71, that's 6 values. Now, the way that we're used to counting is, like if you count from 0, you don't usually count 0. And that's kind of one of those things that, because we're counting in distance when we're counting like that. We're counting the number of values in there. All right. And I think that's probably one of the reasons why you get people all in these uproar when discussing whether the millennium starts at 2020 or 2021. At 2000, yeah, the number flips, but you don't get a full year in until the end of that year. So that's what this is amounts to. It's two different ways of counting. But if we're measuring the distance or the actual time span, like with years, then 1 year of the new millennium comes, at December 31st. All right. So I'm going to go ahead and write these. You know what? I just remembered something. Let's see if I can. I found this new board. It's actually the Google board, although I'm not 100% sure. How to? Oh yeah, okay. How to do it yet? Well, I'm working on it. So I'm going to show you that. It's another board, unlike the one that. This is a board too, but I'm talking about the one that you're usually writing on. Well, I found this one from Google, and I can give it a name. And then one of the neat things I can do with it is I can drop an image into it. And I'm going to copy, I'm going to put this image in here and then I'll show what I'm talking about. Rather than having to type all this stuff out again. All right, so also too, there was some data over there. What in the world happened to my data? It's like it got erased or something. I'm gonna have to go back. Then I'm gonna have to make up some. I know it was in here. It just must have got erased during class one time. Because the way that I'm make these notes dynamic. Anyway. So I'm gonna bring it over there in a minute. Hold on a second. I'm almost finished. All right, so all right, so here's some data. And so what we got to essentially do is we're going to go through and we just need the I'll show you what we're going to do here. We're going to put a couple of labels up here. This is what we call the class. And then over here, and then what I'm going to do here is I'm going to put the count. Now, the count and the frequency are essentially the same, or maybe I'll put it as a different word. I'm going to put tally. Now, this is not part of the frequency distribution. It's just how we're going to keep track of everything that goes into it. So, so 67 would go in that one. So I'm going to put a line there. And then I'm going to mark it out. 85 would go into this one. 74 is going to go into that one. 88 is going to go here. 75 is going to go there. 81 is going to go here. 79 will go right here. 80 will also go there. 69 will be over here. We're up there, I mean. And then 82 would be right here. All right. So I've just gone through and I can look at the number of pieces of data. There were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. All right. So all of these numbers are going to have to add up to 10. So I got 4, 5, 6, 7, 8, 9, 10. So we got what we need. But what we really use for the frequency distribution is not the this. We really wanted to just have a whole number there because that's easier to read. And then this one will give you another 2 down here. So this is what we call a grouped frequency distribution. All right. And then from this, sometimes you can build other things. We're going to see a little bit later. You can build what's called a histogram from it, which is a kind of a chart when we get to charts. But right now we're just looking at counts. So it's important to be able to look at something rather than just seeing a bunch of numbers. Look and see at the at the values there and see how many you have of each. Now it doesn't tell you specifically what those values are like you had down here, but that is the weakness of a frequency distribution. And that's why we've got something else that we'll talk about in just a second. Now, let's just talk about the several kinds of graphs we can use. One of the most common types of graphs is one that most people see all the time when you see it in things in textbooks and articles and such. It's a circle graph or a pie chart. And what it does, it represents one whole pie or 100%. And then you can break data into the individual groups, and each color of pie would represent a certain percentage. All right. A histogram is a bar graph, and we're going to look at that in a bit because that histogram can be used to represent a frequency distribution, as so also a polygon, a frequency polygon. And a frequency distribution is just a bar graph where each one of the bars, the vertical bars, represents a particular frequency that we're dealing with. All right, so let's go ahead. Let's see, where's the best place to do this at? I'm going to do this on the regular board because I know a little bit at least how to do straight lines on there. All right, so what we were supposed to be doing is our assignment. And I'm going to go over here and just copy it and bring it back. All right, so I'm going to go ahead and let's see, where did I? So here was the frequency distribution. Let me just go back over there and show it to you. And if I could learn to do this on this board, I would certainly be in a little bit better shape. But although I'm sure that I can do this on this Google board, I just don't know how often to do it offhand, but I know how to do it on here. All right, so remember we had the 66 to 67. So what I'm going to do is I'm going to just kind of, let's use black. And first of all, I'm going to create the axes. All right, and if there was a ruler on here, it would make it even better, but try to do it as even as we can. Let's see, and there was 1, 2, 3, 4 different things. Okay, there was 66, and I'm going to write it here. '72 to '77. Age 489. All right, and then on this, it's going to have tick marks. Now remember, we had like values. We had basically 2 different values, but I'm going to make tick marks of 1, 2, 3, 4, 5. But 1, 2, and these, imagine these all the same size. All right, so let's just take a gander at that thing real quick that we created over there on that. What was it? They call the Jamboard for. But anyway, I've got these written there. The column all the way to the left on the bottom. And so what I'm going to do for the frequency is put these numbers. So the good thing, the way I picked it is it's 2, 2, 4, and 2. So what I'm going to do then is so there's 2. All right, so there we go. Now, ultimately, and you'll have this tool on your Alex. You can these will get filled in for you because when you do your line, it makes it solid. This is not going to be easy with what I'm trying to do, but anyway. So it looks something like this. So these are solid bars. Imagine that I'm actually doing a good job with the coloring in and not going outside the lines. So that's what we call frequency distribution that histogram that represents that frequency distribution. All right, any questions, folks? What they have in Alex, it's they'll give you the axes, the vertical and the horizontal axis, and then you have to type in the labels at the bottom. And then what they have is the way it works on there is like you go to this little one here, and then you raise up that until you get the bar to the height that you want it for the frequency. And this almost does it like that. It just doesn't fill it in, make it solid. All right, so what do we got next? All right. Oh, and they want us to now, and they also what they want is the polygon too. All right, so that one, I'm just going to do it right next to it. Basically trying to mimic the exact same thing. All right, and now let me make these first, and then I'll tell you what I was going to say. Hold on a second. All right, now the thing that's different about the frequency polygon is it's sort of like a connect the dots thing. And remember, these are all the same here. This part's the same, but what's slightly different is on the left there with the histogram, you have the whole class written out there. That's the values that are in there. All right. For the frequency polygon, this is a histogram. Now they have this thing called the midpoint. If we take, let's see, 66, which is that first one, 66 plus 71, and we add up, I'm going to show you how we get it in a second. Okay, that's right around here. You want to see, it's right kind of in the middle, but it's the midpoint. And how do we get that? So, i.e., for the first one, 66 plus 71, which is equal to 137 divided by 2, which is equal to 68.5. So I'm just going to go ahead and do the same thing on the other ones. 72 plus 73. I'm sorry. 72 plus 77 is 149, and if we divide it by 2, smack dab in the middle is 74.5. $78 plus 83 and then 84 plus 89 is 86.5. So that's the one thing that's different about the labeling is you use the midpoints, and then you don't have to use a different color, but I'm going to just to kind of make it look nice. So there's the 2 there. There's the 2. Here's our 4. And then there's our other 2. And then what we do is we go down here and here to the end. So this is how we make it. Yes, it's essentially just to connect the dots. So there we go. That's what we call a frequency polygon. Okay, any questions about that? So those both represent that same frequency distribution. One is just with a bar chart called a histogram, and the other is using a frequency polygon. Now, some books tend to concentrate on more one on the other. Personally, if it were me, I would just take the frequency polygon out and just concentrate on the histogram, because especially if you go to Math 203, that is by far the most important thing, and I don't even think they ever even mentioned frequency polygons in there. Now, that does not mean that now, I don't think it'll happen for, it may happen for the spring, but they are supposed to, switch to Alex from the system they're using, and it's the same publisher. It's just They use this thing called Connect. It's very similar, and I like the Connect in Math 203 much better because it's made more like Alex, but the way that what's going to be different is that it's that same kind of linear thing that you got to just go through. You're forced to go through everything, you know. You can't skip things. It's going to make sure you go over everything. All right. All right, so let's see. Back to our notes, or back to my notes. Let's see what else we can look up to. The next thing is another one. Now, as I had mentioned, especially with what we looked at with the frequency polygon and the histogram, you can see the pattern of the data. You can see how many was in each one of the categories, but you don't get to see what the individual pieces of data were. But there's this thing called a stem and leaf, which is, how would you say, it allows you to actually keep the original data and see the pattern. Now, we've not, when we looked at the frequency polygon and the histogram, there was only like 12 pieces of data there, so it's not like a large data set, but that's usually the kind that you're looking at in the book anyway, or in the Alex. But you can represent large data sets with that and keep, and it, whereas with a this thing we're going to look at, a stem and leaf, you're kind of really hamstrung on the size of the data. So let's just see what's different about this. All right. It says in an outpatient testing center, the number of cardiograms performed each day for 20 days is shown. And it says construct a stem and leaf plot for the data. Now, the way that a stem and leaf works is you have the first number is going to be your stem, and then your leaf is going to be the second number, or in this case, the stem is the tenths. Tens, not tenths, tens, because that's 20. 5, you're talking about 2 means 20, and 5 is the units. Now, you can make different ones, but the ones you look at are going to be rather simple like this. So what we're going to do is, and I can just kind of write this. And I'm going to let's see, it was a stem leaf, and I'm going to upload that into my the Google board and show you how this works. So let's see what I'm going to start a new one and then do it. All right. So what I'm going to do, I'm going to write it over here to the side on the right. So I was going to mark out kind of, here are the stems you got. You got a 2, 3. So there's going to be ones that repeat. But out of those, you've got a 0, you got a 1, you got a 2, you got a 3, you got a 4, and you got a 5. There's more down here, but those all start repeating. So what I'm going to do is I'm going to put here a 0, 1, 2, 5. So that represents all of the leaves, stems, I'm sorry. All right, so that's the line that separates. Now, what we're going to do, instead of writing the whole thing out, what we're going to do is, okay, we're going to go to this. This is, well, maybe back up. We'll do it in two stages. So we'll go to this one. That's 25. So that means we're going to put a 5 right here. So I'm just going to go through and whack them out as I do them. 31 means we go here. We're going to put a 1. So that right there represents our 31. Oh, you know, I'm sorry. Thanks. All right, so let's just back up. Create and stem and leap with the data. All right, I'll back up. All right, so what we've got with that original data, so as I said, is the first number are the stems, and you can see where I've kind of marked them with red. But that's the numbers that represent what's there on that left-hand side. All right. So that's all those right there. I made an accidental mark on red, but that doesn't mean anything. All right. Well, thanks, Denise, for keeping me on the ball. I'm jumping back and forth, with 3 different things. I'm trying to learn a new, this new tool. And like I said, I can't do everything on it yet, but some of the things that I learned, figured out how to do, I'm going to do. All right. So what I'm going to do is I'm going to go to this first one, and I'm going to mark them out as I do them. 25 means that we're going to have a 25 right there. So that right there represents 25. So that one's taken care of. For this one, it's 3, 1. So 3, 1 is right there. 20 is 2, 0. So that means instead of we don't need another 20 because we've already got it, but we just put the 0 there to represent 20. 3, 2, 32. All right. 1, 3, 13. All right. 1, 4, 43. Yeah, there's a new one, but that's down here. And then 0, 2 is this one. This is the only one that begins with 0. And I think that, in real life, you might actually see it as just a 2. So you'd have to kind of imagine that there was a 0 there in order for this to work. But like I said, they're trying to take it and make it fit into the model here. 57, 23, 36, 32, 33, 32 again, and then 44, 32 again, got to do 52, and I'm marking them out so that I know that I've used them. 51, and then 45. Now, the good thing about a stem and leaf, well, it's twisted on its side, so this is not a good thing about it. The good thing is you can just kind of reconstitute your data now, because you know you got 0, 2, you got 13, you got 14, you got 25, you got the 20, you got the 23, 31, 32, 36, 32, 33, 32, and 32. You can actually see the pieces of the data you got. And also, and which is going to become important, just that we didn't really notice so much what the histogram is, you can kind of see the shape here that the data takes on. And that's going to be important later on for a lot in statistics. The stem and leaf allows you to be able to see the general pattern of the data, that it starts out real low, goes up higher, has a nice peak in the middle, and come back down. All right. We're going to get to that probably by next Monday, what's called the normal distribution. There's data that fits this pattern of being like a bell curves, what it's often called. And an awful lot of data falls into that kind of category. So we can use, I guess you could say, we can take certain things for granted about data like that. And it's going to be, we'll see. It's going to come down. I'm not going to get into it now. So that's what we call a stem and leaf. Now, I can't remember, but I'm just going to show you anyway. So this one right here is unsorted. All right. So what I'm going to do is I'm going to take it and sort it. All right. So what I'm going to do, I'm going to write the same thing again. I'm just going to sort it. So all I'm going to do is just, well, that first one doesn't need to be sorted because it's already sorted. And the crazy thing is that one, second one is too. It's already sorted. This one, to sort it, it would start out with a 0, then 3, and then 5. And then for this one, well, the 1 comes first. Then you got 1, 2, 3, 4 2s. And then we've got a 3 and a 6. And then here you got 3, 4, 3, 4, 4, 5. That one's already sorted. And then the bottom one, it would just flip around. There we go. So that one is sorted. So they both allow you to see the shape of the data, and if you need it to be able to reconstitute the original data, But I think they want you to do both of them. I know I teach this also in my 203 class. There, they do it both ways, and I think they do it in this way too. Because, like I said, it's the same publisher, so I think they want you to do both. All right. Any questions? All right. Let's see. Let's go back over to our note thing and see what else we got. Okay, we can finish. We can finish everything, but it's what's called the standard deviation tonight. I think this basically makes up like I know this thing's got as many sections as almost as 10, but anyway, this is what's called that right there that we just looked at is called organizing data. That's everything that would fall under the category of organizing data. We talked a little bit about the definitions. So yes, then we went into organizing data with several different methods. I mean, you can organize it with these charts and graphs, and like I said, the frequency distribution and the stem and leaf. Now, this is what we actually first do something called calculations, and the first calculations that we do are called measures of central tendency. Measures of central tendency. Now, sometimes these are actually just all called averages, although most people that use the term average in real life are using this one right here, the mean or the arithmetic mean. That's the one that most people know about. And when you're talking about grades, that's usually the one. Like if you have 4 test grades and you add them up and divide by 4, that would tell you the mean test grade. In actuality, what we use, if you look at the syllabus, there's a weighted. They're the weights in there. So like the tests, if I remember, are 25%. My tests are 25%. The midterm is 25%, and then the final exam is 35%. And then the learning path is 10%, and then the remaining 5% are the quizzes, like the practice tests. So it's similar, but it's officially what would be called a weighted mean. Things have different weights. And that's not that hard to do. Like I said, it is. But we're just looking at this is basic mean in here. Now, as we talked about, we've got both a sample and a population. Well, it doesn't matter what we're working with. The calculation is exactly the same. It's just called something different. When you're talking about the population, it's called mu, and it's this little symbol here, right there. That's the Greek symbol mu. It's like a fancy U, but it's called mu, like mu. All right, and then for the sample, it's called x bar. Right, it's just an X with a line over it. But the calculation is exactly the same. What this essentially means for this is we add up all the number of pieces of data that we have and divide by the number of pieces of data that we have. So we're going to do this over on the old board, I think. Make this easier over here. All right. So what are we going to do? We're going to take all right. So we're going to add those up, 5, 7, 10, 11, 12, 15. And then we're going to divide by the number of pieces that there are, which is 1, 2, 3, 4, 5, 6. So if you add all those up, you come up with 60. And then the denominator is still 6. So this comes out to a nice even 10. So, I mean, we could think of those numbers as being anything. Let's just say they were all quiz scores for that matter. You know, if you added all 6 of them up and divided by 6, then the average one is 10. The mean one would be 10. All right. Now, there's another measure of central tendency, and it's called the median. Now, the reason why we have more than one is because each one of these has a specific strength to it, a strength and weakness, actually. Now, the mean, what it does, it gives us the numeric center of the data, the number that's in the center. Okay? A number that's in the center of the data. The median is like the physical center of the data. What we do is we order the data, and then essentially we find the value that's in the center. And if you like formulas, then this is in here. But you got to realize you're talking about, this tells you the position. It does not tell you what the piece of, what the median is. It just tells you in the ranked order of data what is, you know, where is it at? All right. Now, there's two different scenarios. There is when the data set is odd. In other words, if we got 11 pieces of data or 13 pieces of data or 15 pieces of data, then there's exactly one piece of data that's in the center. So if you have 15 pieces of data, there's 7 on each side and 1 in the middle. But if you've got an even number of pieces of data, then there's not just 1 in the middle, there's 2 in the middle. And so what you do is you add up the middle 2 and you divide by 2. And that's what that's telling you here. Like I said, is. But this tells you the position of it. It doesn't tell you what it is. So in my opinion, formulas are not the best thing to use for finding the median, although that's the way they handle them, okay? And then the third measure center is the one piece of data or the piece of data that's most frequently used, the one that occurs the most frequently. All right. So let's do, I'll show you one. I'll just bring this over to the board and we'll do it. Do all of them. All right. So there's 1, 2, 3, 4, 5, 6, 7 pieces of data. So for the first one, mean. All right, so we add all those up. What do those add up to? Y'all gotta be keep an eye on me. 1, 2, 3, 4, 5, 6, 7. Okay. Am I right that it adds up to 61? I'm going to do it again. Oops, not 61. It's 71, right? I'm going to do it again. I'm going to watch what's going on here. I'm going to make you wake up. Okay, so it's 71. All right, so which means that we're going to have to round it off. And generally speaking, you round off to one past number of pieces of data. So the data is all whole numbers, so we're going to go out to tenths. So 10.1. Okay, any questions about that? Okay. So let's do the median. Now, first thing is, so let's say 2, 3, 7, 8. I think I got them. Let's see, 1, 2, 3, 4, 5, 6. Oops, something's missing. Oh, there's two tens. And that's probably what I forgot to do that first time and why I came out. All right. So they're sorted lowest to highest. So now I know this could be confusing. This is why, like I said, you don't really have to handle it like this. But what I'm saying is that 1, 2, 3, 4 because hopefully you can see that that piece of data is in the middle. When I say middle, physically, that there's 3 on either side. All right. So this formula, n plus 1 over 2, will do that for you if it's an even number. If it's an odd number of pieces of data. If it's not odd, then the formula is just going to confound. Well, I'll take that back. If it's even number of pieces of data, it'll come out to like 0.5. So that would just tell you it's in the middle. Show you what I'm talking about. Well, first of all, let's go back to the mode. It's 10, because 10 is the only one that repeats. So 10. So this was the mean, median, and the mode. All right, any questions about those? We got a few more we can do to take us through this. All right, so the next one was find the median. So you have to sort it. Well, you know what? It's already sorted, isn't it? So we're going to look for the 2 middle pieces of data. It's not just one that's in the middle when it's even. There's 2 pieces. So say when you do that, there's 3 on either side. So for the mean, in this case, it's just going to be 21, because if you take 21 and add it to 21 and divide by 2, it's going to be 42 divided by 2, which is all right. So that's how you handle it if it's an even number of pieces of data. If you want to, you can use that formula. Like I said, I don't particularly care for it, but that just tells you that the median lies between n plus 2 over 1. In other words, n is 8. So n over 2 is 4, and n over 2 plus 1 is 5th. So it lies between the 4th and the 5th pieces of data. So you add those 2 up and you divide by. So I mean, if you were to put it in here and you didn't recognize that it was even, well, it was 8 pieces of data, right? So 8 plus 1 over 2, that would be 9 over 2, so 4.5. So that means it's in between those 2. So it means if you get a decimal like that, 0.5, you got to add up those 2 pieces. All right. Now with these, we don't really have to do much. Find the mode. Now, it is possible that you can have more than one mode if there's a tie between the number of pieces of data. So like with this, you got 1 appears twice, you got 2 that appears 3 times, and you got 4 that appears 4 times. So here the mode is actually is equal to 4. But on this one, because you got 2, 3, 5, 7, 8, 9, 10, and 12. Well, let's push it back up. There is no mode because everything is unique. So it's possible to have one mode, no mode, or more than one mode. Now here, 1 repeats twice, 2 repeats twice, and 3 repeats twice. So this one has got 3 modes. All right, any questions about that? I think we pretty much, this next part is not nearly that big of a deal. I kind of got it in there because I can't remember if they put it in there, but it's not a major thing, the grouped data. What that just means is, what was it talking about for the frequency distribution, the one that we did? I'll just kind of go and go back to that board and show you on there. Because we already did part of the work for it. All right. So you remember we figured out what these midpoints were. All right. I think I've got to remember what they were. Let me just kind of go back up a second and do them and look at them again. I know they were over there. 68.5. So I'm just going to take a little picture of them here so I can use it. All right. So now let's go back to that board. We can do this real quick. All right. So we need to have the midpoint for this. And it was 68.5. $74.5. $80.5. Ah. And 86.5. All right, so there was the midpoints. So what we got to do is do one more column. Times the frequency. It's going to shorten it there. So if you do that real quickly, so this is scroll it out, 137. 74.5. $80.5 times 4. And then 86.5. All right, so now what we need is we need two values. We need the total here and the total here. So we already know the total was 10 here. That's going to be the denominator, but we got to have the numerator here. So that's n, and this is just the kind of the crazy formula of it. It's midpoint times frequency n. All right, so if we add all that up, actually it should be not n, it's some. All right, so we got to add that up. Hopefully I can get this real quick. I know we're over time, but I can do this in like real 2 seconds. Well, that's 781. So in this case, it's 781 over 10, which gives us 78.1. And that kind of makes sense because you can kind of look and see where most of them are at right in here. So, all right. So that's all for what they call the measures of central tendency.